the reduction or the appropriate consumption of resources. So primarily, I need not have to talk much about again the background, but how the resources they play major role and why they need to be conserved. That is being highlighted here, wherein it primarily again focuses on energy, water, and materials. The impacts we have been discussing, wherein it has significant impact in terms of GHG emissions. Then you have resource pollution as well as secondary product generation, and then because of your operational energy demand, lot of chlorofluorocarbons they are being also generated. So, looking at the whole life cycle of building an environment where you primarily, we are right now focusing more on materials. So, be it any phase of the construction, and the environmental implications are highlighted. Primarily, if we design or develop better and better system, obviously the benefit is going to be the individual human beings, apart from the environmental conservation as well as resource conservation. A very similar sketch, what earlier speaker has also shown, but this is much evident that because of rise in the infrastructure, there is a demand for the materials or the resources which is continuously increasing and which significantly impact the CO2, wherein some of the alarming important figures are mentioned here, that almost 22% of emissions uh, of CO2 are accounted because of construction activity. And how, because of this increase in demand, also it is projected that how the CO2 emissions are going to go on a higher rate. Now, this is an Indian picture where some of the help what we have taken from ISC, and we could come up with some type of benchmarking about the embodied energy of various materials from the Indian market, and how can we control, that is a secondary role. So we do have primarily the control. So out of 100%, the maximum significant role is of binder, which is being used in all the applications of the construction. And then secondary what you use is steel. So if we look that because of sensitivity analysis or in our designs, if we can control any of these two features, primarily we are going to have a win-win situation in terms of controlling the uh, emissions. On a larger scale, when we start comparing that these are significant values what were supported or what were given by some of the manufacturers, deliberately the brand and all I have removed because of confidentiality. But having said that we have certain numbers available with us, and when you come up with some mixed proportion, how to calculate the embodied energy, it is very simple, because in terms of proportioning we know per cubic meter how much is that going to be the impact. And as we you can see that if the cement is poorer, probably, or the mortar is poorer, your energy value also goes down. Likewise, if you go for lime-based products, which is a natural product, and your energy keep on reducing almost to a 50%. I hope, as majority of you are from civil engineering background, we all know that the binder, what is being developed, wherein for during the clinker formation you need lot of lime, and that is what we call it as earlier when lime was so popular. Now that itself is being used as one of the raw materials for cement manufacturing. So why not to use directly the lime? So that is the holistic approach where you can control the embodied energy of a product. Subsequently, when you still further go into the details about these materials, so per unit volume or per unit weight of the product, how much is going to be the embodied energy, those values were well taken. And if we calculate for a specific, you can say the element of the construction, probably we will get how is this value. Ultimately, the end result value. So earlier you were shown there are certain software tools, also Excel based calculators we can generate, and this you can do it by your simple calculators. So total embodied energy of a particular building, they are shared between so what is happening technologies and knowing the embodied energy values, we can always figure out what is the end or the total energy of a particular product. So again, as a initial or at the initial beginning, uh, what we normally have started with was to gather the data from a particular manufacturer, and when we make a configuration, let's try to put everything on a single page where we can come up with the final energy requirement or the energy that is being uh, which can be termed as embodied energy in fact, and then the control measures can always be taken up with the alternate resources. Primarily now, also apart from embodied energy, that is during manufacturing and during construction. Now let's talk about the third phase, which is operation phase, wherein there are a lot of interactions of heat transfer. So primarily you have radiation, conduction, convection, and so on and so forth. So this is directly the heat which is incident on various surfaces. So because of solid materials, how do you control the Q for conduction? So the rate of heat transfer. And then convection is somewhere where your fluid, that is air, which is involved. So typically, we have been or in the group, what we have a software known as Transys, which is a US based software, but you put lot of inputs and its ultimate output is with the proper configuration. Do we have a temperature control zone? So normally in Indian market, what we or in Indian scenario, in fact, we know the codal guidelines which talks about comfort. So you have SP41, which was way back established in 1987, and now same clauses are also available in your new NBC. So typically you have a range of 18 to 27. So the software like Transys, what it does is it normally helps to calculate the temperature inside a built form based on the given condition throughout the year. And now that itself is a significant challenge where you can always play and plug the different configurations. Say for example, you have a single brick wall, and then I am just adding up some insulator. What will happen? So primarily the moment you say insulator, your heat transfer coefficient will go down as well as resistance will increase. Now that this is how it goes, primarily what the software looks like or what it requires is the material data, which can always be taken up from the material supplier. Then you talk about climatic data, which is well available in the public domain, and then we know what for applications you are using. So it is building usage data. Say for example, any office building. So office building where you say maximum occupancy or maximum usage may be for 12 hours. However, in our homes it is 24 hours. So it talks about usage data, the various materials which are being used, and then we also focus more on architectural element like design data, which primarily focuses on what is the optimum orientation for this particular model, then where the window should be, where the walls and roof they have to be. We do use non-contact type of temperature gun, which primarily puts the laser. And then if you see, there are two models which are shown in front of you, which it terms as thermogram of fly ash model versus thermogram of sugarcane bagasse ash model. And then you check what is the maximum value. So the maximum value of temperature in case 1 was 49.6. However, in case of second, it is 47.2. So there is almost, you need to figure out that more than 2 or the 4% of my temperature can directly be controlled in terms of heat gain. What we look into is the properties of the material. Now, most of the cases where we have been taught that you do lot of physical testing, you also try out with lot of mechanical properties. However, the functional properties are oftenly overlooked, and that is what one kind concern what we feel, that you need to understand or we need to have some knowledge of thermal conductivity about the material, so that while picking up the product you can always do trend of analysis where cost becomes optimum and temperature or the total performance is also within the particular range, that is 18 to 27. So how India looks like? So in India we have various climatic zones. What is more important, some of you might have seen, some of you might be using it, but we call it as ECBC, that is Energy Conservation Building Code. And now here you can see we do have in our country there are 5 different climatic zones. So these pictures are directly I have taken from codal provisions. Now you see where your structure lies over a specific zone. So what you have to do is you go back to your India map, see where we lie, and put the specific value of u, and then accordingly do the calculations to check what is the thermal resistance, how what is going to be the heat gain, and so on and so forth. However, when you just try to figure out the embodied energy of building material, it is being said that your concrete is very less percentage of application. Then we have subsequent increase in the materials embodied energy, and then how to replace it. That only you have to just one can make couple of comments so that those can be wind up here. Yeah. So now moving further, the graphical photograph or the graphical presentation of all the type of materials is shown typically, which is there in our Indian market. Now here, for cement, some inputs are mentioned, how it is being produced, so that we should know in fact how a product is being manufactured. Say for example, if you just try to figure out the way of manufacturing a particular masonry product, so your objective is to find appropriate raw materials, the appropriate water to cement ratio, and after that, probably you need to perform multiple tests with those particular products to reach out to a conclusion whether it is feasible or not. So there are a lot of ways of doing it. So one of the ways, you have calcium oxide, then silica oxide, alumina oxide, metal oxide, and CaSO4H2O is found, which are normally found in case of limestone. So the materials without gypsum are like proportion to produce a mix with the desired chemical composition. Now again, the important aspect as a material scientist or from the environmental perspective, what we need to figure out for a place like Nagpur where heat is predominant, we need to have more and more pores or cavity in between. Again, the workmanship is a challenge, because if we get very less number of these, uh, you can say the panels or any material, then that's going to be the challenging task, where how it is being manufactured, that is again matter of study. So just to show a picture that how a process of particular generation of cement is challenging. So now here it is been showed that there is no dust, no soils, no no vibration, landscaping impact, and raw material limestone that is not near the particular products where they are lying. Now, secondly, we are also talking about the gridding, that is, you have noise, dust, and electricity. In case of clinker production, they have like SO2, CO2, and then couple of couple of air pollution challenges which are mentioned, and then steps are also given. So looking at these aspects, it is always preferred that from you can say first unit to 10th unit, everywhere there is going to be the challenge related with environment, and we need to take control of the production measures or the losses. Now, very similar to the binder, same issue could be with the aggregates, and then we need to find out certain alternate aggregates, the origin of the aggregates, from where they are, what are all their particle sizes, how do they gel with the alternate binder, and then so on so forth. So there could be n number of examples where we can quote that there could be n number of natural aggregates or the alternate aggregates that can be pitched in instead of the alternate material. Now, for aggregate extraction, some of the points are mentioned, like last class also, as I said, that is, we need to create pits and quarries, uh, typically, which is not good, where you may lose fertility of soil over a specific patch. Then coming back to the second point, which talks about uh, like last class also, as I said, about the aggregates. If we are doing quarrying, we are going to lose the life on Earth, which is also one of the themes of sustainability. Then adjacent ecosystems are affected, maybe because of some of the other pollutions, what we discussed in earlier class, wherein noise, dust, pollution, and contaminated water could be the potential threats. That is what the government has highlighted. Next, we talk as the laborers, they are not in habit of even wearing gumboots or t-shirt because it's very, very odd time. However, during this time, if somebody wants to use the particular toilet, then that's going to create more issue. Some of the aspects related with fine particles where silica is there, they are specified here. Now, to debate with the alternate binders, do we have direct solution or do we have challenges? So first is how, what can be the USP for alternate binders. So maybe if you are ready with some solution, we can always discuss. However, the challenges for the conventional one are the GHG emissions, or also government issues what we have for the conventional material. Then you talk about technicality, where we say conventional material has already proven itself as a durable product. Then we talk about the special properties, which also focuses on the ability of the product, that is how good it gels with the other raw materials. Then do we have the alternate raw materials which are at a lesser rate, and then the various applications, say for example, you may require UHPC as compared to conventional concrete for a specific application. So these are some of the field-based issues. Coming to the economic aspect, you need to benchmark your cost for a conventional material and what best we can give. That is the you can say the story, but what one can take forward. Then we also know if it is a novel technology or a novel product, probably cost is going to be the constraint for all of us, and how to address this particular challenge, probably for which we need separate deliberation. Then we talk about, obviously, as I said, water also we use for lot of applications. So we need to check how good it forms a bond with the raw materials. Then you also talk about the test associated with alternate raw materials, including the toxicity leachate protocol test. Then you talk about the demand. So obviously, market as it is continuously growing, we know that cement pricing will, although it grows, however, its demand is continuously increasing. Barriers exactly vice versa. That uh, long-term building data, and then we also have uh, particular product standardization not only in India but abroad, where we can always focus on alternate binders for improving the end. You can say the project. The more important is when you say something which is new, which is different, probably there will be less buyers, probability of failure, because it's very tough to convince the conventional technocrat that yes, this is a next generation product. After 10 years, you won't see anything beyond this. So you should also conserve water. Now, coming back to the applications of skills, where you say you have OSHA guidelines, then you have another important aspects which primarily focuses on the policy formulation which needs to be done for specific type of alternate binders which can be marketed in India separately. So when you come back to the cost, because we also have learned something about life cycle costing. So your cost depends on how much resource you have involved for exploring a particular raw material, acquisition from the source. Do we require certain permits? Say for example sand, so you cannot have sand just like that from riverbed. You need to have the approvals. Same is the case for setting up of any plant like cement. You need approval, so there's a cost which is involved. Then you have environmental controls, which are essentially one needs, any organization need to comply. You have regulatory compliances, which needs to be monitored and maintained throughout the life of a particular, you can say the operating company. And then obviously you need to figure out some reclamation plan. So, just to give you an example, there are certain names which are mentioned where you can modify your aggregates with the raw materials, which has, you can say, better clinker. Further, we should also know it's like basic part is economics, and also on the second part, what is our focus is we need to check if I am substituting a conventional material with an alternate one. We need to check the performance of that product in terms of various properties like physical property, chemical property, and in case of physical, then again some more parameters are mentioned. This we have already seen, but again, I'm just giving you a quick flash that over 25 years, how India has grown for this mission of decarbonization, sustainability, or energy efficiency. So maybe as we started from somewhere in 2000, where first audit was carried out, and then subsequently construction of green building had happened in Hyderabad. Later it moved to the Teri because they have been advocating something for energy. You have, so we have various stakeholders, and then now the better part is you do have a lot of key players or the standards which are enforcing us to do better and better or greener business where there will be lesser carbon footprint. So, do we have range of products? Answer is yes. You can log. So this is it. Like with Griha and IGBC, there are certain product catalogs, so one can always use which are low carbon materials. How to look into the rating system, that I need not have to let you know, because we know as the point system increases, rating ka grade will also increase. Moving next. So coming back to the sustainable building materials, if we start counting on a scale of 100, how many points I can cater only if we focus on materials. So significantly it is 6 plus 5 plus 4 plus 2. Ata- like coming back to the top one, if I add the bonus points, then probably the story makes sense. What is it? Like it's more than 20% what we have to discuss or what we have to focus in case of decarbonized urban infrastructure or conventional infrastructure. Here, these are the standard templates which are available at IGBC website. You can download and you can train these kind of empty models for your own application. Wherein, if we see somewhere, what we are doing is equivalent or the energy efficient equipment, and you also talk about metering. So the main agenda, what right now we are focusing is only materials. So let's target that at least in 1 hour, and then we'll see that if the time permits, we can go also to an extent of water saving measures. Yeah. So coming back now, how the system it works here, if we see, can we replace? So the standard it directly says that we have the liberty to replace the high energy material with the alternate material to a tune of 30%. Now this is what it makes sense, and then here it also talks about utilization of wastewater. So if water that is available to a tune of 50% of the demand, that can always help. Now these criteria are essentially required to convince either the contracting agency or a builder that it's not going to affect a lot, and then one can go ahead instead of having conventional or a virgin material. Let's go ahead with alternate products. So here we focus more in terms of ecological, social, and equitable solution in terms of. So the principles of sustainability, let us extend them beyond three conventional principles or R's, where you talk about reduce, recycle, reuse. We also say we need to focus on the act of composting, and also domestic for solid waste. You have certain cans which creates a major issue, or it is normally one time use, but what do they do, that we need to verify. SDGs we have already seen. Now here I just brought the multiple photographs indicating there are different issues in different photographs. If you look at the top, probably the roof is going to be the challenge. However, from the top, if we look into third row, wherein you can see even walls to some of the villages, they are not at all constructed. In turn, what is the philosophy then to use a better product is this, where you really plan to design something. So for designing, you need to identify the alternate raw materials. Apart from alternate raw materials, you also need to check the waste a particular company is generating, and can we then bring down to a ground reality or blend it. Now, again, the earlier what have I shown, but the primary concern is the amount of secondary resource which is moving here and there. Like here it is some values they are mentioned wherein it talks about how to bifurcate some of the other materials, and then those materials can be a part of this conventional issues. So now coming back to the Swachh Bharat Abhiyan, where I will directly jump to the second point, where you have certain C&D waste recycling facilities uh, for whatever population we have. Secondly, the amount of C&D waste in India has estimated 10 to 20 million tons annually, and these are so look at the international standards where you talk more about the usage of this and enforcing the rules for the waste what we generate. So the philosophy is, can we reuse it in terms of circularity, and this is what India is still yet to make a benchmark contribution into the specific utilization of any raw material. However, the just to gain the faith that do we have success stories, answer is yes, where recycled concrete building structures they already exist. Coming back to the stakeholders, we say we will require support to make it bring for various levels, where you have someone from central agency, somebody from state level, somebody from as a faculty, developer, and then fastest generator. So wherein all of us, if they can join hands, we can solve a one particular issue of utilization of aggregates. Do we have enough number of CNDA solutions? Answer is yes. Coming back or looking into the depth of standards, again it says for a specific application you have maximum limit of fly ash which is being given to mile industry or the mile side. Now, a simple step, what earlier researchers they have developed, where you have primary raw material which goes for screening, then you go for crushing, then secondary crushing, then screening and dust removal and sand washing at the chamber. So these are the steps as we discussed yesterday. Where can we cut down any of the process which is going to help by and large to the industry? So one need to be on quarry and then do some R&D and then give the solutions to the particular industry. So some of the examples where you have portable C&D waste managers who can help to come on site and then settle the issue of space requirements. So as per the NBC guidelines or probably the waste raw material, there are a number of ways how do we want to use it, and then its applications are also mentioned in the same table. So conventional raw material that is also tough to get in a place like Nagpur, and that is a challenge where you use lot of GBFS, and then you have fly ash. Then one can always substitute sand, and then if we come up with a concrete. So now here when we say that conventional raw material fails in the edges, probably water will start percolating. So wherever there is water interaction, one needs to go for waterproofing and then proper treatment. Or the quicker solution is you invite an expert, take his opinion, and then just add some feature to it on campus. Now, proportions of raw materials which were tried at different level, and we can see the comparison for various trials what is happening, and as the comparison is being like leaded with the front side, 2.7 will somewhere, so the total weight will be reaching earliest. Now coming back to this CNT waste production, where lot of work was done by Dr. Vedehi, and then you were trying to control its density as well as performance. And here we go, where the total chart of conventional versus the developed product is indicated with reduction in the percentage of density as well as embodied energy. So the last column is important, where you say change in value is somewhere around 7 if we continue doing the same business. Also, the water absorption is shown to be in the range with like this has no admixture in it, which came somewhere maybe a year ago. Then you would also talk about thermal conductivity, which goes in control. So overall, we can say burn energy, how it is being tracked for various organizations. So coming back to the some of the products which we can have a business case with this waste, with the help of recircular economy is you can make lot of concrete products, masonry products, dry masonry which can be sold in the market with proper labeling of the data what you will be generating. When it comes to the greening, it says that control the production limits, which is again a challenging task because there are a lot of people who are involved. Then we also talk about use of waste for fuels in case if it is required, then that can be done. Yeah. So now coming back with the change in the population, what is its impact? Those are mentioned. Then improving particle packaging of building dimension for carbon. All these references or the sites I am leaving up to you because you need to go through them for some or the other application, maybe day-to-day practice if it is required. Now, after replacing the ordinary Portland cement to Portland pozzolana cement, there could be some of the key players who will be playing major role. And as I said earlier, that like your course aggregate, although they look smaller, but they have bigger role to play in India. So right from sand, silica fume, etc., etc. So various materials which are there, those can be specifically used for a particular application based on the intervention or the scientific study or the access to the laboratories. If they are available, then only it is workable. So to an extent, if I present here multiple products, so where you have bacterial concrete, on surface you have calcium carbonate precipitation by your bacteria as they die after 24 hours after finishing their food. The major concern is again the excess heat which you need to control. And then you have special type of concrete where foam concrete most of us are now aware, but it took almost 15 years to come up with this product, but still we are connected, so that makes sense. The third type of concrete where we are also dealing where slope stabilization can be done with the help of canvas concrete. Same is the case. So in 2016, there were like paper waste which is being dumped to the uh, which is normally dumped, in fact, can be converted into the workable concrete. So here, this is a success case where you talk more about living in paper from USA. Coming back to our cases, once you go to the some industries, and this is a ricer's cash which goes back to the industry and then come back for construction of materials. So there's a separate recipe for each and every component. It is very, very challenging. Conventionally, we do 4 to 5 or 3 to 4 tests. Here, each and every product needs to go through more than 30 tests. Then only you can say such product is good enough to work with. So we can see the surfaces of the products. We can check the chemical composition. We can also check whether it is smooth surface, rough surface, and so on and so forth. Now, this is a microstructure analysis where you can go the bottom one where one can always understand what is the kind of uh, nature of the product in terms of crystalline or amorphous. Here it shows that gravimetric analysis, how that has to be done, and where is the major mass loss after ignition. So you get certain features out of it. You see how the product works, and then you come up with the various blends to design a product. After blending, you get the strength, and if the basic performance indicator is achieved, all other tests can be done. And then once this technology is ready, probably can we shift to the you can say local market, for which recently VNIT is planning to execute the task for VIDC. So regional spaces can always be tapped, and we can always give better solutions to the techno-social issues. So in nutshell, if we design a product, you see it has to be better in terms of density, having higher compressive strength, and probably control water absorption, including low thermal conductivity. uh, I believe that if the product or something is designed through this process, so as I said initially, it's like big business of around 30-35 talks, which needs to be done into this premise. So the primary objective here is we need to check the structural stability also. So if we just compare that whose peak is bigger, we say for blue it is much higher as compared to red. So if we just know that, probably we get to know that for the maximum displacement, maximum force, and maximum bending moment. So I mean to say force and momentum, they can directly be correlated. However, shear is very much needed, so we are formulas are going to that. So coming back to one case where we say that how this particular product is going to behave better, and in turn we can see for mass production or for a bigger project, it will give or it will reap us a better solution. Uh, Morning also, Viraj shared something for your BIM. So I need not have to do lot of exercise again, but we know how to model a particular structure and how it is going to give us a shape in terms of application of these kind of uh, inputs, wherein at the end you will get reduction or the control of peak cooling demand. So if you just see with the help of the sketch or the figure what I have shown you, based on the solar geometry, you get to know the cooling demand for various locations, and at the end, with the help of software, you can check that almost how much is the difference or the deviation in the control of this particular material. So, if we are designing certain product using the philosophy of circular economy or circularity, you need to come up very clearly the takeaways for a specific case, wherein the objective for the product when it was to be designed, we had that in mind that density should be light, it should be energy efficient, it should be durable, it should be thermally insulated, then it also should provide a solution for solid waste management, and then uh, control of natural resources. So making it sense. So we take the story further, wherein we say that the product is designed, what is then end application. So we started shifting that do we have better picture, and then here it shows that in physical reality when we have put the sensors for G+1 structure, almost 6% of the control of the temperature inside the built form was compared and found suitable. As I said earlier, what is a better product? We say better product where you do not use cement, but for which you need to do lot of exercise with the molarity of concentrations of certain chemicals, which can always be tried as a substitute of sand. So again, it goes with certain matrices where you do lot of operations and then you come up with a final value, and then directly it can be tried in some of the existing setups what we have in VNIT. You can see almost 45 around combinations were tried in terms of various meeting the various basic compliance requirements. Normally, for designing a product, you require huge support of your codal provision. So, if we say that such type of products they are available, they need to compete not only with your durability or particular strength properties, but also the functional in terms of environmental impact and then cost as well. But obviously, as we say, that in this product we are adding more and more waste, which requires, if at a smaller quantity, you may require some pre-processing, but if it is large in weight, larger in size, and it is only the transporting the end product that will be done in the next uh, slides. So I'm just taking these numbers fast because that's a huge database. So what we are coming up with the same combination of various raw materials ingredients, if I change the proportion composition, you generate various type of resources. At the end, you have to report what is going to be the best for your case or for your uh, you can say consideration, so for which then we design something and then reach out to the strength of minimum compliance requirement. Here we go for one of the important properties. Now we have digital one also which needs to be used, where you can find the thermal conductivity of the products essentially, which is to be used as one of the inputs for most of the software tools. So you get the cost recorded energy in terms of usage of resources, and that is what one can report. So if we have a bigger picture of designing, say entire resettlement or entire redesign, then structural performance needs to be evaluated. So we will never take a guarantee in terms of putting up the reinforcement because it has to be inside. So in case of computational analysis, again, you can do energy analysis. You can also do cost analysis in terms of life cycle costing. So what we are targeting, probably my colleague Professor Rajesh Rishi also must have focused on this at a city level. How do we talk about? So this is one of the urban slums. What was tried here? You can see almost more than 300 dwelling units when they were planned together with the novel typology. So you have defined dimension of the structure, and then based on the typology, we design it in Revit structure analysis for various applications. So G+1 structure. This is the urban slum, and then based on the dimensions and the properties of the products, you come up with something like this. So you have particular quantities of material because estimation is also important part, and based on the cost you can see that which type of structure is going to cost which type or how much amount of money. So maybe if you incur or have an additional slab, that's going to change the figure. So here takeaway is not the percentage because this was against one particular quantity, but one can always compare with the better and better options. So in both the cases, you can see how the story is changing for embodied energy, for base case as well as load bearing. And in case of load bearing, obviously more weightage will be for your uh, masonry as compared to your steel. So steel got reduced, and also you can check that the total embodied energy of case one, that is conventional one, and the second one, how they alter. So parallelly, we just compare both the options, and then for both the cases, you can see peak cooling demand has gone down for dwelling one, dwelling type of one to dwelling type of two by almost 19%. So here a brief case and the numbers are shown because to gain these numbers you need to work on the system with the help of software tools so that you can get better outcome in terms of percentage comparison, and we will not create any uh, in case kind of design issues as far as embodied energy is concerned. So this is it, like what we have proved, that in case of circular economy with the help of alternate raw materials, if we take the story from designing till execution, then what's going to be the change, and the cases were compared for cost, energy as well as reduction in operational energy demand. The outcomes presented in terms of small structures, multiple products were I think shown to you, and you can see the big contribution that is coming up from all the researchers for specific property or for specific material. So in nutshell, if we want to showcase that multi-story structure that was designed, what are the takeaways? So because measurement monitoring is also important part as far as the decarbonization is concerned, here when we are recommending alternate raw material with the proportion, obviously the cost of your other features, they will get controlled. The better aspect is like you need to establish with very good facility as far as experimental, then we also call it as computational. So the both of them, once we compare or once we make a bigger story, that becomes here in case of reduction in peak cooling demand, which highlights the case for case 1, case 2, it reduced to 80 like by 20% with a base case what we talk about. So for environmental evaluation or the particular areas, those are targeted are climate change, embodied energy, then life cycle analysis and life costing analysis. So just a brief overview. What is LCA? Again, it also focuses, if you talk that one can discuss more about reuse or waste minimization in any particular scope of the work. So LCC, it is helpful for comparing, for evaluating various options, what's going to be the payback period, and so on and so forth. So just to help out the consultants, there were multiple consultants which were taken into consideration, and then a tool was designed, in-house tool, wherein you just try to check what is the carbon, and if that carbon footprint is not there, you need to have alternate properties so that equivalent material can be tapped. So you have various flowcharts, but here what we are trying to talk in terms of materials and then earlier time. That's it. So I'm almost at the end where you talk about this. This tool is being developed by Dr. Vedhi madam. So if you have any queries, you still have one day to go. If you want to have hands-on, hope she must be having access with this tool, and then uh, it can be worked out. So here you have to choose a particular consultant for whom she has designed the entire emission factors. So you just have to add the material, automatically you get some factors, and then the total carbon footprint is being evaluated or estimated for a particular product. So if you have any queries, we can have a quick discussion for another 10 minutes, or we can you can be just free. The session is, I think, till 3:30. So I just finished this particular part so that 5-10 minutes we can discuss a bit in detail. Or even I can show you some another cases what we have designed as far as energies are concerned, or the embodied energy or carbon footprint in terms of recycled products. There is something, any possibility to use pond ash as a residual of coal? Yes. So there is a RMC plant in Mumbai who are right now making use of pond ash to an extent. But what kind of initial treatment they are doing, that you need to again check. But people have been doing this. So ultimately, now we need to understand we do not have resources available which are conventional, and then we need to figure out how do we work. So we have another researchers who are also here working with uh, the aggregate, or you can say manufactured aggregates, or then you have further to that polymeric aggregates and so on and so forth. But still days are yet to come because we need to work with the standards. So what have I shown you is something which is already available in the standards. That type of business can always be taken up further. I'm just waiting for some queries. In the meantime, I can show you something more. If you have any queries, you just type there. Do we have any other queries, or I can just take up quickly next 5-10 minutes more about the principle of circularity? So I can connect you with this, Punit. I can connect you with this particular RMC plant which is in Mumbai, and you can just talk to them. Right. So how do we report the output? That is again important. So just wanted to showcase few things here. Yeah. So more on the part of taking the story further with usage of alternate or the blended products, how the things go, wherein we pitch more on TRL as well as MRLs. So hope all of you are aware about technology readiness level as we are proposing better and better or innovative technologies and product in circular economy. We need to understand, although this evaluation is one component, before we pitch the material, we should be very good in technology, then demonstrating it. So as we have already demonstrated a lot of cases on campus now, where we talk about deployment to a level of TRL 789, and once this is proven, we can also think on the market readiness level of these products. So I'll come back directly to the cases where you do lot of feasibility analysis. This table indicates how much amount of a particular resource is available of a particular business case, and then from that on, after analyzing the products, you should be good enough to understand the product, to understand its chemistry, and then blending of those products. So after blending, you come up with the best product, and then for a particular product you also compare its uh, mechanical properties, physical properties, ease of handling, and then you propose some better and better ways. Next to your I hope some of you are physically available who have seen our smart classroom. So next to that, this pod is available where I hope Bhagyashree can take care of it, or Manoj, any one of those volunteers, they can brief you about what is this. So we call it as a pod. So this is a jointless construction. Again, here you save lot of energy and resource in terms of manpower. This is fully you can say uh, self-compacted concrete which is poured in the volumes or the uh, formworks, and then particularly you come up with the desired shape, which is a multidimensional shape of a particular structure. So here we also compare again the costing, which can again come down. Maybe if you do it on a larger scale, that is what we are convincing the manufacturer. You design the shape and size of a product, and then you fix up with a particular energy analysis again, which one is better. I hope to an extent for LC analysis, Srirang also must have shared something, but this art you need to understand. OpenLCA is again one of the tools which is available to a larger extent. Earlier we used to use Athena and all. Uh, there were few tools which were available, but now this is one of the tools where you try to model your entire structure and then check the impact in terms of how the carbon emissions are or can be controlled. And here you have certain potentials. So you primarily talk about global warming potential, that how much it is getting controlled in terms of novel product or the contribution of each and every raw material in the end output. So this is repeating. I have shared this. There are few more cases. So every case is different, unique. We have certain demonstration on campus. Probably, if that, I hope Madam yesterday must have shown you to majority of you. But small scale modeling technique is one of the technology or the technique which you can always try out at your hands. And then once you feel that this particular technology is worth enough promoting to the masses, then that can be demonstrated as a full scale model. So most of these models are one third scaled model. Uh, Also, here this is the one case where you talk more and more about use of alternate raw materials and then establishing a business case for socially deprived communities. This is the recent one what we are working with. So this is a prefab technology, but these demonstrations, what I just wanted to touch with this is these novel products where you try to pitch something with either zero cement or either no sand, or you have alternate aggregates. Those are being pitched in terms of development of secondary structures. Ultimately, what I wish that, as we have discussed yesterday, also we just this we wish to have the better networking. Although we are very well connected with the local industries, probably in your local region, again with these novel concepts, probably if you can collaborate and upscale with the industries, that's going to make sense. So we are trying to have more and more industries on board, where you have prefab manufacturers or the product development team in R&D labs, collaboration with the other universities. So those are all some of the initiatives which talks or which shares us, where we can share the common platform where we technologies can be shared and can be demonstrated across the boundaries. So if there are any queries, I'll quickly answer, or we can just stop. What is the service life of newly developed green material? Yeah. So this also we have checked, and it is as durable as that of conventional concrete, and we could get a better strength. So uh, I have not shown in any of my slides, so because that data needs to be still published. However, the life what we are envisaging as per NBCs, we have checked it for almost 50 years. That's going to be workable for conventional concrete, like the conventional concrete. There's a Is there any significant difference as far as life is concerned? I should say no. However, as of now, as the age will grow, we will get to know. But most of these products we have demonstrated over 3 to 4 years. So I believe that till now there are no issues in our small scale models. So if the workmanship is controlled, or as these products are better designed in the factories, probably we may have lesser issues on site. That is what our perception is. So last 5 minutes are left. If anything is there, I can continue, or we can stop here, and then maybe we can wait for the next session. So may I close the presentation, and then can we disperse for another for the next session? Still, if there are any queries, any issues. So if there are no queries, that's fine. All of you just see to it. Everyone gets the access to all the slides which were shown, because tomorrow you have to appear for the exam. So there are last couple of sessions which are left out. So I look forward that all of you take active interest to listen to it, and then at the end you have to appear for one small objective test, wherein everybody should get as best as they can in terms of understanding the knowledge or gaining the knowledge, and then finally it will be done with the course as of now. Fine. So let's close the discussion, and then we will meet 3:45. Hope somebody is there from my group. Bhagyashri, Manoj, Yuvraj. Is
Yes,
there anyone?
yes.
Yeah. So I am just